In this video, we're going to talk about a couple of ES6 features that make it much easier to work with objects when it comes to creating objects and when it comes to accessing properties on an object. Then we'll take what we learned and we'll actually integrate it into the weather application to improve it. But to kick things off, let's go ahead and create a brand new file in the playground directory. I'm going to make a new one starting with the number 5, and we're going to call this 5-ES6 objects.js. In here, we're going to mess around with two new features. Then we'll take what we learned and integrate it into the weather app, and that'll be your challenge for the video. Let's get started with the easier of the two features, which is the object property shorthand. This allows us to add values onto an object with a shorthand syntax under certain conditions. So to kick things off and explore how this is going to work, let's make two variables. I'm going to create a const name and I'm going to store my first name. Now for this example, the variable names are important, so make sure to use the same ones I use. Next up, we're going to create a constant called user age, and I'm going to set that equal to my age. Now from here, the goal is to create a user object. So we're going to set that object up. We want their name and age coming from these variables, and I want to store their location, which I'll just set up right inside of the object definition. So name comes from the name variable, then age comes from the user age variable, and finally location comes from an inline string. So right here, I'll just define my current location, Philadelphia. Now we have an object and we could print that to the console and we wouldn't get any surprises. So right here, console.log user. I'm going to save the program and run it just to make sure things are working so far. At this point, we are not taking advantage of the new syntax. Down below in the terminal, I'll use cd:/playground to switch into that directory. From here, I'll clear the terminal output and run my new script. That's going to be node 5-ES6-objects.js. And when I run it, what do I see? I see my object with those three properties, name, age, and location, with the correct value for each. Now let's talk about the object property shorthand syntax. This syntax can be used when defining an object like we're doing here. It comes into play when we're setting up a property whose value comes from a variable of the same name. And that is exactly what we do here. We're setting up a name property. The value comes from a variable with the same name, and that means we can actually use the shorthand syntax. So what do? We remove the colon, and we remove the variable name, leaving what just looks like the property name. But this is actually a shorthand syntax. When we do this, it's going to create a name property on user whose value comes from the value of the name variable. So in this case, we are going to get the exact same result we got before. Down below, I can save the file with the new syntax in place and run the script. What do I get? I get the exact same thing showing up. Now it's important to note that the names need to match up exactly. So we have age right here, but its value comes from the user age variable. That means we're not going to be able to take advantage of the shorthand syntax like this because there is no age variable defined. If I do try to use this, we're going to get an error when we run the script. Down below, I can run the program in its current state, and what do I get? I get a reference error. Age is not defined, and they're right. There is no age variable. So when we do want to create a property whose value comes from a variable of a different name, we still have to list that out. But here we can use the shorthand syntax because the property name we're trying to create does match up with that variable name. Now, this is not an earth-shattering feature that's going to make your programs faster or more scalable, but it is a very nice syntax improvement, and I take advantage of it constantly, and there are a few places in our code where we can take advantage of it as well. Before we worry about integrating this into our code, let's go ahead and explore the other feature, which is going to take a bit more time. This is known as object destructuring. Now, object destructuring is useful when you have an object and you're trying to access properties from it. So let's start by creating an object we can work with. Let's get started by defining the object we're going to destructure. So right here, const product equals, we're going to set up an object, and we could say this is an object for a fictitious inventory system. Let's say for our store, we have a label for each product, which is shown on the shelf below the product. I could call this one something like red notebook. And from there, we'll add a couple of other properties into the mix. I'll add price. Let's say this notebook is $3. I'll add the stock. We can say we have 201 in stock. And finally, I'll add something like sale price. And we'll say that the item is currently not on sale by setting the sale price property equal to undefined. Now, from here, we can go ahead and use destructuring. The whole goal of destructuring is to extract object properties and their values into individual variables. So instead of a product price property, I could have a price variable with the value of 3. Or instead of a label property on product, I could get access to a label variable with the value red notebook. This is really useful, especially when you're working with complex objects that have a lot of properties you're constantly referencing. It's nice to have those standalone variables that you can easily use. We can achieve the same behavior without a new syntax by simply creating individual variables, like a const label whose value comes from product.label, and we could do the same thing for something else, like a const stock whose value comes from product.stock. Now we have a label and stock variable we can access throughout the rest of the program without having to grab it off of the object each and every time we want to use it. Now the problem with this obviously is that we end up writing a lot of code for each one we want to extract. So we're going to have multiple lines to pull off multiple values. With destructuring, we get an improved syntax. So I'm going to comment out those 2 lines, and down below we'll explore the destructuring syntax. Now, I'll admit it's going to be a bit weird at first, but I promise you'll get comfortable with it as we use it more and more throughout the class. So to start, we are indeed still trying to create new variables, so I am going to set up const, and in this case, we are going to, after const, add a pair of curly braces. We'll talk about what goes inside of there in just a second. After that, we are going to set it equal to, and this is where we put the object we're trying to destructure. In this case, I'm trying to pull values off of product, so I'm going to reference it right there. Now let's do the same thing we did above. Instead of accessing product.label and product.stock, I want an individual label and stock variable. To get that done, inside of the curly braces, we list out all of the properties we're trying to extract. So that would be label, comma, followed by the next one, which would be stock. Now the space in between is completely optional. I typically add a space when I'm working with destructuring. And now what do we have? We have individual label and stock variables, which we can use down below. And to prove it, we're going to log them. So console.log label, followed by console.log to print the stock. And if we run the program, we're going to see that we do indeed get red notebook, followed by 201. Down below, I am going to rerun the program using the up arrow key and enter, and when I do, I get the 2 values that I just mentioned we would get. So with the destructuring syntax, it makes it really easy to extract properties off of an object, creating individual variables that store those property values. So in this case, we are pulling a label property off of product, we are getting its value, and we are creating a new label variable, and we're doing the same thing with stock. We're creating a new stock variable whose value comes from the stock property on product. When you are destructuring, you can grab as many things as you want by listing them out in a comma separated list inside of these curly braces, and that could include properties that don't exist on the object at all, like rating. Maybe I'm storing a star rating for each product. There is no property defined up above, so what are we going to get as the rating variable? Well, we're going to get undefined. Down below, console.log, if I print that new rating variable, the program isn't going to crash because there's no property rating. It's just going to store undefined, and that's exactly what we can see down below. Now, there are 2 other nice things we can do with destructuring. One is that we can rename the variable we end up creating. So let's say that I want to create a label variable, but instead of calling it label, I want to call it something like product label. But obviously, I'm still trying to get it from the label property on product. To do this, we use the following syntax. We list out the property that we're trying to grab, followed by a colon, followed by the new name. So in this case, product label would be the new name we want to create. So this is going to create a new constant called product label, who gets its value from the product label property. Now let's go ahead and test this out. If I run the program in its current state, it's going to fail. There is no longer a label variable defined. We have renamed that product label. If I reference product label, we're going to see this time around that things will indeed work. I'm going to rerun the program, and now we are correctly seeing red notebook print. So being able to rename the variable we create when destructuring can be really handy, especially if that name happens to be already taken. Maybe, as an example, we already have a label variable up above in the program and we can't use that down here, but we still want to take advantage of destructuring. One last little feature we get when using destructuring is the ability to set up a default value for the variable should the object not have that property. We could do this for label or stock or rating. To explore this, let's do it for rating, since there is no rating property up above. Right here, we just say rating equals followed by a value. Let's say if there is no rating property, we will use the number 5 as a 5-star rating. Now if I run the program, we're going to see 5 print. It's important to note that this default will only be used if there is no property matching on product. If there is, the default won't be used. So for example, if I set up rating, let's set it equal to 4.2 stars up above. Now that value is going to be used instead of the default. We can save the program, we can rerun things, and that is exactly what we end up seeing below. Now we can also use destructuring when we're working with function arguments. That's the last thing we're going to cover before we move on to the challenge where you're going to use these two tools in the weather application. Right here, I'm going to comment out all of the code we have for destructuring, and we're going to create a function that takes in that product object. So right here, let's go ahead and create a function. I'm going to create something like const. I'll call this transaction, and we're going to set it equal to a function. And this function is going to expect 2 arguments. Let's say there's a transaction type. Am I selling a product or am I placing an order? And let's say we also need to know the information about the product that we are making this transaction with. So I'll call this something like my product. Now we can pass that value into transaction using a very basic syntax, transaction, calling it with those 2 arguments. Let's just use the string order as the first argument, and then we'll pass in our object as the second. So right here, we have an object as the value for my product. Now, if we wanted to destructure values off of that, we could just add a line down below. Const inside of curly braces equals my product, and I could destructure something like the label that would indeed work as expected. Now we have a local label variable we can use. But we can actually take things one step further and destructure the argument right here in the arguments list. So instead of giving a name for that argument, we simply set up the curly braces, and now we can destructure whatever we want off of that variable without ever having access to the whole thing. So right here, we're going to have access to just the values we choose to destructure. I could, for example, destructure label, and I'll destructure something else like the stock, 2 values that might be important when making an order, and down below we can use them. So console.log, I'll just print out the type, followed by the label, followed by the stock, just to make sure all of those variables actually exist. If I rerun the program down below, what do I see? I see the order type, I see my label, and I see the stock printing, all getting their values correctly assigned. So when we're using destructuring, we can destructure a standard object outside of the arguments for a function using the syntax up above. If we know that an argument is an object, though, we can always destructure it right in line. Both are perfectly valid, and we'll end up using both throughout the course. That's where we're going to stop for this one. Now that we know how to use the property shorthand syntax and object destructuring, in the next video, it's going to be up to you to use both in the weather application. I'm excited to get to that challenge video, so let's go ahead and jump right in to the next one.